In mid-2026, the U.S. government launched Pursue, a massive interagency effort to declassify unidentified anomalous phenomena files. For many, this was the moment. The expectation was that the government would finally pull back the curtain and reveal a hidden fleet of reverse-engineered alien spacecraft. But the Department of Defense's All-Domain Anomaly Resolution Office also released a comprehensive audit of 8 decades of classified programs. Their conclusion is blunt. There is absolutely no empirical evidence of off-world technology. To address the physical evidence directly, the government brought in Oak Ridge National Laboratory to test the most famous materials on record. They analyzed alleged spacecraft fragments from historic crash retrievals, checking to see if they exhibited extraordinary anti-gravity properties. The lab's findings were entirely mundane. The highly touted specimens are standard, terrestrial manufactured alloys like magnesium bismuth and aluminum. Despite relentless public searching and endless conspiracy theories, nobody is hiding a stolen alien blueprint that will magically jumpstart human space travel. If we are entirely alone and there is no secret saucer to reverse engineer, how close is human science to crossing the interstellar void ourselves? To answer that, we can look at this interstellar viability scale. This is a conceptual map we'll use to track ideas as they move from debunked myth and science fiction through mathematical reality all the way to functional engineering. By filtering out the UFO noise and focusing strictly on this scale, we can see that humanity is making quiet, profound leaps in advanced propulsion. Let's start on the theoretical end of the scale. In 1994, physicist Miguel Alcubierre proposed a mathematical concept for a warp drive. His idea was to achieve faster-than-light travel by physically contracting the space in front of a spacecraft and expanding the space behind it. This Alcubierre visualization required impossible negative mass to expand the space behind the craft, leading scientists to dismiss it. But physicist Eric Lentz recently discovered how to construct hyper-fast solitons using purely positive energy. A warp bubble can theoretically be powered by conventional physics. Warp drives are no longer blocked by the hard laws of physics. They have officially crossed the border from science fiction into mathematically viable reality. Moving slightly further down the scale to physical experimentation, we find Dr. Salvatore Pais. Working with the United States Navy, Pais secured several highly controversial patents for advanced propulsion. His core theory, often called the Pais effect, relies on a device called the high-energy electromagnetic field generator. By creating extreme high-frequency electromagnetic vibrations, the generator attempts to polarize the quantum vacuum around a craft, theoretically reducing its inertial mass. The Navy took the math seriously enough to spend $500,000 testing the concept. However, they failed to prove the effect actually works in a laboratory setting. Manipulating the quantum vacuum sounds incredibly promising on paper, but for now, inertial mass reduction remains an unproven concept stuck at the experimental barrier. Advancing to the far right of our scale, near-term physical engineering, we hit the Breakthrough Starshot initiative. This project launched with heavyweight backing from figures like Yuri Milner and physicist Stephen Hawking. The physics behind this are completely grounded. The plan relies on a massive 100-gigawatt array of ground-based lasers to propel gram-scale light sails, known as star chips, through space. The ambitious goal is to accelerate these probes to 20% the speed of light, allowing them to cross the void and reach the Alpha Centauri star system in just a few decades. But in 2025, the project was placed on indefinite hold. The engineers ran into severe real-world roadblocks, including the extreme difficulty of keeping the sails perfectly aligned on the laser beam, and the catastrophic damage caused by collisions with microscopic interstellar dust. Even when a propulsion method aligns perfectly with the laws of physics, the brutal realities of constructing macro-scale infrastructure can still bring progress to a grinding halt. So we return to where we started. There is no magical spacecraft sitting in a classified hangar waiting to save us the trouble of engineering our own future. There is an immense gap between writing mathematical equations for positive energy solitons and the physical ability to build a functioning laser light sail. The failures of the Navy's mass reduction tests and the delays of the Breakthrough Starshot program are not ultimate defeats. They are the grueling, necessary friction of the scientific method, acting as a reality filter. Humanity has pulled interstellar travel out of fantasy and firmly established it in the realm of real physics and math. Now, we just have to figure out how to build it.